Okay, sorry guys, my computer ran out of space for videos. So let's keep going here. Now on the x-axis, you'll notice that I have whatever the event is that's going on. So what are we looking at here? We are looking at the number of goals scored in that hockey game. So that's whatever is on top of the probability, or what's the story about. Again, we're looking at the number of goals scored in a hockey game. So that's what my x-axis is again. Again, to scale it, whoops. Look at the min and the max. So our minimum is 0, our maximum is 9. It's easy to just go by ones on that x-axis. Now you'll notice then, if I look at 0 goals, the probability is 0.061. So I make a bar over the 0, up to around 0.06, over and down. How many are the probability for 1 goal scored in a game, is 0.154. You'll notice then I went up, the bars are touching to the 0.1514, over and down. And I continue that process. Again, the bars are touching in this. Let's review then, how do we describe? When we describe, we want to use SOCS. The first S stands for shape. This one looks a touch skewed to the right. So just as a quick review, symmetric looks like this. Skewed right is where we have more of a tail on the right-hand side. Skewed left is where we have more of a tail on the left-hand side. Again, it's slightly skewed right. I'm sure someone might make an argument for symmetric, but because of this little tail right here, I am going to say for the S, the first S, I'm going to say that this is skewed right, okay? The O is, are there any outliers? No, these are a little more extreme, but they're kind of hovered all around together. An outlier is almost like a lonely point. There's a big space and then a dot. So I would say, no, there's no outliers that we can see right now, okay? The center would be, okay, if you could now, this is right now for the center, you are just going to estimate what you think this, or approximate, eyeball it. If you could pick one number to say, on average, this is the number of goals scored in a hockey game, what number would that be? And I'm going to go ahead and I'm going to say somewhere between 2 and 4, okay? Somewhere between 2 and 4. And some of you are going to feel uncomfortable, but just, you know, do your best here. You are just approximating or estimating based on this graph, okay? And then the spread is just right now, just tell me what is the range. That's your max minus your min. So our max minus our min right now would be 9 minus 0, which is equal to 9, okay? Again, for now, all you're going to talk about that. Eventually, our center is going to be our expected value of the distribution, and our spread will be our standard deviation of the distribution, okay? But that's eventually coming up. So let's go ahead, let's go back and look at our problem. For the NHL goals, we talked about what makes it legitimate. We talked about how to graph it and describe it. The last question here is, what is the probability that the number of goals scored by a randomly selected team in a randomly selected game is at least 6? So what does it mean to be at least 6? At least 6 is 6, 7, 8, or 9. That's at least 6. So what I am going to do right now is I'm going to add up the probability of at least 6, looks like this for a statement. And I'm going to go ahead and I'm going to add up those probabilities. I'm going to take my calculator. I'm going to put those in my calculator. 0.041 plus 0.015 plus 0.004. Oops. Plus 0.001. And that's equal to 0.061. Okay, so again, what do we need to know? What makes something legitimate? How do I make a histogram of this data? And how do I read the distribution, okay? And answer probability questions based off of it. We should feel good about that. Let's move on what I talked about, and that's that expected value. That's gonna be part 3 of the video.